64 encoded video container, and when you pulse it, it's going to grab the most recent frame, essentially. Yeah.
So if I play the MP4 hypothetically, then what ends up happening is I just see this like crazy, like.
Yeah, you would just see just like that if it's at 5 meters or whatever.
But then because the pulse hits all the cameras at the same time, what ends up happening is we can kind of guarantee synchronization of the frames, even though they're separate video streams.
Right. That's correct.
Tablet computer here. So like the images are getting punted back via USB 3. Do you have any issue? Like, do you have any problems with a hard disk rate? Like the SSD drives work just fine?
So this is a low res preview.
Yeah.
Of what's happening up in the.
Or the photos are being stored on the device, not on the computer.
Yeah, they're being stored inside of the camera.
Oh, because it's got a little SSD.
Yeah, it's got this guy inside of it.
Not little.
Yeah, not little.
Yeah. So they come up with size 2 USB 3.1 interface up to 2 terabytes.
Yeah. Okay, so it's being stored there. It's not transmitting back.
Yeah.
But then is there a way, like, do customers ever redo the calibration? Like, is that a thing?
So we provide a GRP file for the Mystica VR Stitcher.
Okay.
And what you can do in that is if you wanted to adjust the color balance, or say you wanted to orient the camera in a position that we didn't normally have it oriented in, you could try and correct like the pitch, roll, yaw there and create a calibration file for how you specifically mounted your camera. But if you wanted to do something like Kevin's done, getting the intrinsic, extrinsic values of all the lenses and all that stuff, we've provided you with that kind of data before. So,
yep.
It can be, I can get some fairly complex requests that I have to kick up the chain of command.
Yeah. Cool.
When we get an image stream, we also, after the post-processing software is done, we get an MP4 that is panoramic, right?
Well, you'd get JPEGs that have the EXIF data embedded in them.
Okay, so we will get frame by frame JPEGs, but it's all panoramic.
Yeah, it's all stitched together.
All stitched together, and then we do have those JPEGs are all real time, right? When I say real time, they're synchronized to a pattern like that 5 seconds.
Yes, they're all synchronized, all the same exact time.
That 5 seconds. So if I'm running the same clock to trigger my 0 point on the LiDAR, I'm basically all synchronous.
Yeah, so you're talking about like a hard, when you pulse the camera, is it going to give you a frame the second you pulse it?
I don't care about the relative positioning of those triggers for the cameras. Well, all the cameras need to be triggered at the same time. That's a given.
Yeah.
But then LiDAR can be 2 seconds later, but it's always 2.00000 seconds later.
I got you.
It's not a little bit less, and it's not a little bit more. So we're basically taking the image, and it's always at 5 seconds. I mean, every 5 seconds. And it's if I synchronize my trigger to the camera with the trigger to the LiDAR, and there might be a delay in between, but a known delay with no jitter on it, I can actually have a very accurate fused data LiDAR plus camera.
Right, so, and that's been encountered by other customers where, you're running at 10 frames per second, recording all that data, you trigger it. The moment you trigger it, you're actually halfway through, like, capturing that data, right? So what it's going to have to do is capture the next available frame, which might be like a couple microseconds later, right? So that, like, a little bit of a differential, but
your accuracy is kind of at that
1.7
meter level.
Calculated error of 1.7 meters right now.
Yeah. So if I was integrating this with the span system, so I've got an IMU and an external GPS, how hard is it to then link up? Like you'd mentioned, there's an SDK, or that we can access this via REST APIs. How hard is it then to synchronize up the camera to the span system that I'd be using?
Well, there's already like integrations done with certain equipment manufacturers, but basically you just talk to the guys in engineering and find out what the specs are for what you have, and you could use the RS-232 or auxiliary ports that are on the camera. And typically the way that works is like if you're using that XVN, for example, all that pitch, roll, yaw information, as well as RTK position data, is just going to be stored in the camera, just in the storage, just like in your route.gpx. It would just, all that digital data would be there.
So it'll actually, so I would be able to send the position and orientation information to actually be encoded into the stream as the video is being recorded?
Yeah, just as if we
opposed
were
to having
using our own antenna.
Cool.
Yeah.
So then I'd be able to export EXIF information, but it'd be correct EXIF essentially.
Yeah, and you wouldn't have to do extra steps in processing.
Yeah,
You would just go,
that's super handy.
batch it, and you're done.
Yeah, that'd
Yeah.
be really cool.